Hello. This is the incremental path to observability. So if you've just realized you've made a terrible mistake, I'll give you 30 seconds to run out of the room. I won't judge you. Awesome. Good. OK, we're all here for the right thing. My name is Emily Nakashima. Thank you for having me. Day to day, I manage the engineering and design teams at a small developer tool startup called Honeycomb.io, which is based in San Francisco. I originally come from a front-end engineering background and design background, but I love back-end development and ops. I used to be the front-end developer who was always hanging out with the ops people, and then I did that for too long, and they added me to the on-call rotation, and I was like, I made a terrible mistake. I know. And then really this last job has just been about being a front-end developer, hanging out with ops people all day, trying to wear this elaborate disguise so that they don't notice that I'm not one of them. And I basically just feel like this every day, except not with a suit because it's a startup and nobody wears a suit. In the past, I've worked at big companies and small companies. The thing I like the most is working on developer tools, and in particular, I love monitoring and observability tools. And Honeycomb itself, of course, is an observability tool. Our goal is to be the fastest and best way to understand what is happening in your production systems. So we are an observability product, but we also believe that observability isn't something that you can go buy. So what is it exactly? Observability is a term that has a long history in control theory, but the definition I like the most is that it's the practice of instrumenting your code so that you can understand the state of your system just by observing its outputs. So people talk a lot about observability tools, but the most critical piece of observability to me isn't where you're going to send that data ultimately. It's how you're instrumenting your services and how you can use that data to answer questions about your code and what your users are really doing in production. That particular variant of that observability definition that I use and that a lot of people I know use comes from Charity Majors, who is Honeycomb's co-founder and CTO, and she's also my boss, so if you know her, just tell her Emily's talk was great, really liked it. She has said this a million different ways, but she always manages to be shorter and more memorable than me, so you can also go with her definition, which is, can I ask new questions about my system from the outside, understand what's happening on the inside, and do that all without shipping any new code? So that all sounds good, right? We want our infra team to be able to do that so that they can quickly figure out why they just got paged. We want our application developers to be able to do that, to debug their code quickly if they just ship something to production and aren't sure why it's not behaving the way they expected. But it all sounds well and good until people take this hard look at that first word, instrumenting. So what do we mean by that exactly? Instrumentation is going to be how you're going to collect the data that we just talked about that's going to drive that whole observability thing. Usually the answer to how you get that is either you're going to write this code yourself to collect that data, or you're going to take someone else's code and drop it into your app. So yes, if you had this response, that sounds like a lot of work. That's the right way to feel. People are skeptical that they're going to find space for this in their roadmap, or they worry, maybe we don't have the right talent on the team to write that code. I think that if you decompose it into pieces, it's manageable for almost every team. Certainly, if your organization can do DevOps and go through that kind of transformation, I have complete faith that you can do this too. This is a smaller thing to bite off, I think. And there are a lot of different routes to get from zero to observability. So I want to break down the path that my team took to get there, and then hopefully save you from some of the pitfalls that we ran into. A logical question that you might ask is, why should I trust you? Like, aren't you on a team full of observability experts? Like, don't you do this all day professionally? And that's a good thing to be skeptical about. I would say that on my team, Charity's an expert, Ben Hartshorn is an expert, but we have folks on the team who have never worked with any kind of monitoring or observability tool before they join, and they're also able to jump in and do this just fine. So it is definitely a teachable skill. You don't have to be like an ops wizard to get started. And more to the point, we're a tiny early stage startup. The engineering, product, and design organization is about 12 people in a company of 25. And like any early startup, our focus is on building the product and the company as fast as we possibly can. We can't spend a lot of time on things that don't move either of those forward. So I looked back at all of our old projects and tasks and kind of did the math going through our project queues. And when we're building a new service or feature, we're probably spending maybe 3% of the initial project on this kind of work. and then probably 1% of our time, or maybe a little less than that on an ongoing basis. I think it was 1% of pull requests were related to instrumentation, but they tend to be smaller compared to feature code, so less than 1% of our time overall. And if you were wondering, like, do these characters represent people on your team? Yes, absolutely they do. These are totally my coworkers, and this slide is in here to figure out if any of them watch my talk after the fact, because if they do, I know I'll get a mean Slack message about it, and if they don't, so I'm gonna figure it out. So this talk, I'm gonna talk about how you walk that incremental path from 0 to observability, and how we tried to fit it into our regular project development lifecycle in kind of a reasonable way that didn't feel like drop everything, work on observability. So for each step, I'll talk about how we did it, when I think it makes sense to do it, what the rewards are, and then when you know you're ready to move on to the next step. And I should say, I'm going to show a lot of screenshots of Honeycomb, the product, unfortunately, because that is the thing that we're building. But none of the stuff I'm going to talk about is product specific. There's other event-driven tools out there like New Relic Insights, tracing tools, log and metrics vendors that can do a lot of this stuff. So I'm really focused on the process and the code that you need to do this, and not on the tool itself. And if you want a little cheat sheet to remember the outline of this talk, this is it: metrics and logs, events, tracing, and then the Galaxy Brain version is how to not shoot yourself in the foot with tracing, because it turns out that there's some pitfalls there. So metrics and logs, traditional observability tools we all know. Don't worry, I'm not going to talk about them for too long. Some people want to suggest that observability is about throwing all these things away and doing something new, and I don't think that's true at all. I think we still make really good use of our metrics and logs, especially for like host-based alerts, aggregated alerts, and we still look at these a few times a week. And of course, the huge benefit here is that we can get going with these really quickly. Everyone on our team knows how to work with them. I wasn't there when we first set these up, but our requirements were just fast and cheap. So for metrics, we picked a SaaS. I think we used signal effects. The pricing model was a little better for us than some of the other options out there. But there's a lot of really good options in this space. Just pick one. For logs, we actually aren't doing anything fancy there at all. So we're just writing text files to disk the old-fashioned way. We don't use log aggregation or anything like that. We have hundreds of hosts running on Amazon, so if we do need to go look at our logs, like SSHing in and grepping through the logs is not very fun. But for us, looking at logs tends to be a step that happens fairly late in the development process. So we're using our alerts to tell us where to look, and then going there and looking at logs is usually a final step, so it's pretty targeted. In fact, if you follow Charity on Twitter, you'll know that she's constantly reminding us that SSHing into any server at all to look for logs is really an anti-pattern. Yes. My boss gets to be inflammatory, I get spreadsheets. But her point is that SSH gives you this illusion of control. So it's relatively easy to SSH into one server and try to understand or fix something, and so it starts to feel reasonable to do that. And then you talk yourself out of writing the automation that you need so that you don't have to do that again, or you talk yourself out of writing the alerts you need so that you can trust that the system will tell you when it gets to that state. So that's what we're trying to avoid. So that said, that's aspirational even for my team. We still use SSH a fair amount, especially if we're like looking at a panic or stack trace and trying to figure out a particular bug. So as long as our tools are telling us where to look and the process of getting that data is a few minutes or less, we still feel okay about it. So quick recap, how do we do these the lowest effort way possible? This is the basics of production visibility, so we don't encourage people to skip this as a starting point. And then we still use these for host-based and aggregated alerts, and logs are still great for compliance, honestly. Like, they're the cheapest way to keep a record of everything that happened. So we're not getting rid of these anytime soon. So when do we know that we've run out of the benefits that we can get here and we want to move to something else? In our case, it's where we start seeing these high cardinality questions that our metrics and logs can't answer easily. I think the classic example that I see is like there's a weird bump on that graph. Maybe you look at your dashboard and you see a bunch of weird bumps that are all correlated together, but when you try to dig into them, you just feel like you're chasing the same bump from one graph to another, and you don't really understand which thing was the driver behind that. Another good example would be customers writing in and saying, I have this problem, and like you can't reproduce it, but it's persistent for them. So the good signal to move up the incremental path to the next step is that you're spending hours or days on these kinds of questions, or it's not feasible to answer them at all. And that typically means you would benefit from like a high cardinality solution. So that's the point where you want to jump and start investing in events. And it'll pay back in quicker incident resolution times. A quick interlude here. I want to talk a little bit about what we're doing with our logs because I think it's important. If you aren't structuring your logs yet, this is the #1 life hack to take away from this whole talk. When I say logs, we do format them in a special way. So we're a Go shop, we use structured logs. Structured logs are key value pairs, they're self-describing, they're human readable just like traditional logs, but that structure lets us do some cool things with them. We're a Go shop, so we use a library called Logrist to do this, but there's lots of popular options out there. And they're definitely getting better for languages that are not just the new hot stuff like Go. So if you looked for a structured logging library like more than a year ago and felt like you didn't find a good option, now is actually a really great time to go back and look again because I feel like in a lot of language communities it's gotten a lot better over the past year. There are also services out there like Cribble and Logstash, so if you want to do log transformation through a service, you don't want to go retrofit all your code to do this, you can also do that. That works too. So what do structured logs look like? That's a structured log at the top. The line below it is an unstructured log. And the funny thing about these is they have the exact same information, they just look really different. So we do write them to disk without the new line, so I just sort of formatted it to make it a little easier to read. Structured logs for me spark joy because they play a lot better with our different analysis tools. And the funny thing about them is if you squint at them, they look a lot like events, which are going to come up next. So that's the last reason we like structured logs. They are a good transitional step to using events. So you can send them to your events backend as though they're events and kind of use that as that kind of halfway step between logs and events. So for us, once we had the MVP of Honeycomb up and running, we started sending our structured logs there just to kind of play with it. Like I said, we're not a log analysis tool. We don't do distributed grep, but there is some overlap. So you can see all your log lines listed out in time order, and then you could do the same sorts of like graphing you could do with a log analysis tool. So this is just a count of GET requests to a particular service group by route. If you're just sending one big string someplace, like parsing and indexing all those fields can be a little slow, it's a little more work, so the structure kind of makes it often easier to do this kind of thing. For us, we still look at these pretty infrequently. Like I said, we're not super log driven, but it's really nice to have when we want it, and it does save us some of that SSHing. So structured logs are almost events. What actually are events? Events can look exactly like structured logs. They might even be structured logs. So all events can be represented as structured log lines. Not all structured log lines are events. Like structured logs, they're key value pairs. The difference is in what they represent. So an event should always represent a complete unit of work for your system. You want to capture an event about every important unit of work in the context of that system. So for a lot of services, that's going to be an HTTP request, but it really does depend on what's important to your system. So for example, if the thing you maintain is a pipeline job and you're not as concerned about requests, one event might be one item going all the way through the pipeline. So contrast that with logs. You can log anytime. A log doesn't have to represent a particular thing. You can log when you get a request. You can log when you have a weird condition in your code. You can log when you see an error. You might even log twice about a slow operation, once at the beginning, once at the end. So in the event world, you don't do that. You roll all those things up, and you put them on that one event as metadata. So here's a typical event we might send from our customer-facing web app. Our best practice is to make our events as wide as possible with as much context as possible. So any metadata that's ever been relevant to like a bug or incident we've debugged should be on there. There's a bunch of fields related to the HTTP request itself. So these are typically things that are going to come from headers, the IP address that this is requested from, the URL, what content they're going to accept. There's also a bunch of stuff about the environment that our code is running in. So like what host are we on? What is the CPU and memory usage, that kind of thing. And then we have a very small number of fields, but these are some of our most important, which is this is app-specific context. So things like the user ID and the team ID. So those kinds of things, those are that high cardinality data that I'm going to talk about. I'm going to say this term a lot, so I just want to clarify exactly what it is. A low cardinality field would be one with few unique values. So like HTTP status is probably a really good example of a low cardinality field. You know, you're probably only going to ever use maybe like a half dozen HTTP status codes in your app. A high cardinality field is going to have many unique values, maybe in the thousands or millions. So some of the most common examples that are relevant to a lot of web apps would be like email address, IP address, user agent, team ID, customer ID, any of that kind of thing. Feature flags are also a really interesting example here. If you use feature flags in your app, by themselves, they're not high cardinality, like the value is going to be true or false. But you often want to look at the cross product of a bunch of feature flags to say, how does someone who's in this group and this group do? And a lot of metrics tools that don't support high cardinality are going to kind of fall apart in that case. You can't look at both of those together. So a high cardinality tool will help you see that kind of thing. For us, like I said, team ID, dataset ID would probably be the things that would be most important. One of the other interesting things we like to know is what pricing plan the customer is on. So sometimes if we see something go wrong in our API server, if it's a free plan customer, that might change how fast we respond or what the response is versus if it's a, like a pro tier customer or something like that. I know, capitalism. So this is a great thing. If you're choosing a new tool, this is a great thing to ask your vendor about. Like, what is your support like for high cardinality? Is there a maximum number of values I can send in a particular field? Is there a maximum number of values you'll render in the UI? Will things get slow if I try to attach user ID to everything? Some of them support it, some of them don't. A lot of the time series database vendors, like Influx, for example, have gotten a lot better at this recently, but it's still worth asking about. And finally, people look at that example event and go, that makes sense, but like, how much code does it take to send those? It's not as bad as you might think. We have a lot of example code on our website if you want to check it out for yourself. But it's typically a few lines to get going and then like 10 to 50 lines to start adding basic context. So from our own code base, that first helper function is how we're going to send the event and how we're going to attach the context that's useful in this handler. So we're adding a user ID. And then the bottom is maybe a typical handler function in our web apps. So the only things about it that are kind of interesting is the second line is where we call that helper function to make the event. And then below that, there's a line that does a little bit of Go magic to say, okay, at the end of this function, look and see if there was an error, and then go back and attach that to the event so that we can send the error state that we don't know about until after we're done running this function along with the event, which is kind of cool. And then the rest of that code block is just about doing the kind of standard stuff you'd expect, render the template, respond to the request. So in sum, writing event instrumentation code, not that scary. There's some boilerplate you need to write to get started, but it tends to be really simple code. It's just a little verbose. I think the last time we did this for a new service, it took a couple hours. So where do we actually put that code? I think our best answer for people is to start at the edge. You want to instrument the surfaces your customers or clients touch first. So this is a very goofy picture of our architecture. For reasons, all of our services are named after dogs. And so on the right side, you'll see customers send events to our API. The API service is called Shepherd. Shepherd does authentication, authorization, and validation. And then we write all those events to Kafka, which we basically use as kind of a big buffer between the API and our storage engine. The storage engine is called Retriever. Retriever is a distributed kilometer store that we wrote ourselves. There's a strange loop talk about that. If you want to watch that and hear more about that, it's pretty cool. And then when customers want to query their data, they open the browser. The browser is going to talk to the web app. The web app is called Poodle. I didn't name it. I was very offended by that name. I was like, it's a very frivolous name for a very important app. But someone pointed out that poodles are working dogs, so I'll take it. Anyway, Poodle knows how to query the storage engine. We also have a service called Doodle that renders static image snapshots. So if you share a Honeycomb link in Slack, that's the service that's going to render that PNG that we're going to show in Slack. And then Basenji is the proxy for our secure product for customers who have like data encryption or compliance requirements. So they run that in their own infrastructure, and then it will encrypt and decrypt. So we only store their encrypted data. So this is a lot of surface area to choose where to instrument. Like, where do we start? We always say start at the edge. So in this case, that means like Poodle and Shepherd, those two services that customers are going to talk to most directly. And why is that? I like to go back to what my boss Charity always says, which is nines don't matter if users aren't happy. I think when we're writing this kind of code, it's really easy to get very focused on the complex parts of our system, like what if Kafka's not working? Like what if Retriever does something strange? But it turns out that if our customers can't talk to them using our UI and API, it doesn't actually matter how they're doing. So, we kind of take that customer viewpoint and we try to use that as our guiding light. So what does that get us? There are categories of questions that, like I said, were trivial with events and hard without them. And my favorite category is the mysterious metric spike. So I used to spend a lot of time digging in Graphite, and it was really common to see all those spikes, like I said, the correlated spikes, and never be able to figure out why they were there. So this is the example of a problem like that with events. So this is a graph of the size of the JavaScript that we're sending to our customers' web browsers. The top is the gzipped file size, and then the bottom graph is the uncompressed file size. And you'll notice that the uncompressed file size is kind of slowly growing, like week after week, which is not great, but I can live with it. It means we're shipping new features. But you notice in that top graph, there's like a couple of big dips where we broke our instrumentation code. Just pretend that those aren't there. So what happens in that top graph? It has these funny spikes in the first 2/3, and that's when clients request the uncompressed version of the asset. So it's a little weird, but it's expected. But we have that strange kind of tabletop formation on the far right side. What's going on there? All of a sudden, it seems like things flip, and these ungzipped requests become the norm. Gzipped requests are suddenly the outliers. Oh yeah, there's the tabletop. So we have these graphs on the dashboard. Chris Toshak, who's on the engineering team, and I walk in one morning and we look and we're like, that looks weird. What's going on there? So Chris has this theory. What if some browser changed how they record the size of assets that are loaded from the cache? Like, are those now considered uncompressed? I'm like, great theory, I really like it. So we're fiddling around in Chrome DevTools. We can't reproduce the behavior, but we're like, maybe some other browser is doing this. Like maybe Firefox shipped a new version or something like that. Maybe it's only Firefox on Windows, you know? So with events and metrics, I would probably stop here and go, like, that's a great theory. I'll come back to it if I ever need to really figure out what's going on. With events, we can keep digging a little more. It's pretty fast. So we just start testing these theories. This is the test of the browser version theory. We took our 50 most popular user agents and graphed them as a line. And looking at that, it's pretty clear there's no correlation. All the major browsers, including Firefox and Chrome, are in both sides of that low and high shape. So we're really confused now. Toshak's new theory is that maybe an attacker or bot is spamming us, and they don't set the right headers to get gzipped content. So that's when we flip back to that kind of raw log view and start going, okay, like what do these requests really look like? And we can kind of see requests that look legit to us, like they're from IP addresses that we know, or they're from people who are actually customers. Like, okay, we don't think it's that either. So finally, we switch to this heat map visualization, which makes that weird spike even more obvious. Like you can see that that original line is very constant, and all of a sudden there's just this new thing happening. So remember, we were putting all those fields on our event. This is where we just start looking at each of those and going, is this field correlated to what changed? This visualization shows for each field how many values were inside the big spike, which is the yellow, and how many values were outside the big spike, which is the blue. This is nice, but it's a convenience. Like you can just run all these queries manually in whatever tool you're using too. So we're looking for cases where the yellow bars are making a very different pattern than the blue bars. And these are the two that really jump out to me. The one on the left is the Goji pattern, which is sort of an abstraction of the HTTP endpoint shape. Like it's like the page URL with variables subbed in. And then the actual page URL is the one on the right. And you can hover and see the values. And it turns out that all the values point to this one subset of our pages. So we'd ship this live demo site. Nobody in our team looks at it because it's a demo. It's like a marketing thing. And we're like, we don't need that. Nobody ever reports anything wrong with it because the people who are looking at it tend to be like prospects. Like they're not usually people who have a relationship with us. None of us had noticed because we don't ever load this site often enough to notice that it's slow compared to the rest of the product. So I really love this because I think that, it's that path of going from the mysterious spike to like, oh, here's this broken thing. And I think it took us maybe 30 or 45 minutes to get there. And I think in my old metrics life, I would have spent like days staring at this and I just would have given up. I do want to say a quick word about tool choice, because I know like some folks in the room are probably new to event-based tools. If you can get a tool designed for events, that's great. Honeycomb is in this category. New Relic Insights is another great tool in this category. There's a few more. But I would also say, if you think you're likely to adopt a tracing tool in the near future, especially if you're someplace where it's hard to get approval for new tools, which is most places, there's a lot of crossover and functionality, so I would encourage you to just like push for the tracing tool and skip ahead. Log analysis tools actually do a lot of this stuff too. The big difference there is usually speed. So tracing and events tools typically are oriented toward getting you an answer really quickly. In log tools, you might need to like run a query and go get coffee. So just play with it a little bit and see if you feel like you can really debug in those sort of iterative loops. And if you absolutely can't adopt a new tool, like you can get some of this functionality out of metrics too, especially if you have good high cardinality support in your metrics. So if you can tag things by request and user agent and look at graphs, you could look at that same set of graphs we just looked at. So in some events, how do we start? We start at the edge. Why do we want to do that? To be able to understand our code faster. It gives you context and high cardinality support. And when do you know that you're ready for the next step? Well, in our case, we were ready for the next step because we decided we wanted to build a tracing product, and we were like, I guess we need to add tracing instrumentation. For everyone else, I think the answer is you should start thinking about tracing when you are spending a lot of time doing back-end performance debugging, especially if it's like an app server talking to a database. If you're spending a lot of time working on bugs and the origin of those bugs is unclear, like you have a bunch of services and you're not sure which service has the bug, tracing is really good for that. It really helps you isolate where it's coming from. Or if you have a microservices architecture that's so complex that people on your team don't actually have a good mental model anymore for what can talk to what, that's definitely a case where I would recommend doing tracing instrumentation. You really need tracing instrumentation there to even answer, like, is my system up? Is it doing what I expect? So what is distributed tracing? Events are a great breadth-first tool. You start with a 1,000-foot view. You start zooming in. Traces, to me, are the opposite of that. They're the perfect depth-first tool. They're about digging really quickly. So we had this event-based instrumentation in all of our services. We decided to go back and start adding tracing instrumentation. In our case, I think for tracing it's a little different. You don't want to start at the edge. You want to start where you have the most complexity. So the first place we started with was our query engine, then our web app, and then finally our API service. And I think that's also roughly how I would order those things in terms of their internal complexity, or at least in terms of how afraid of them developers on our team are. So just to pause really quickly here, this is a good thing to really dwell on a little bit. What is the difference between events and traces? Because there is some confusion. Different tracing data models, different vendors use different names for these kinds of things, but you'll see the same concepts, just described a little differently. You can think of a trace as a collection of events that are connected together by a specific set of fields. So events are usually called spans when they're included in the context of a trace, and then they have fields like trace ID, parent ID, span ID, and duration that allow us to understand how to connect them together when we render them in the UI. So this is like a classic example of a trace, which I'm sure you've all seen before. I think the interesting thing to note here is that every bar on there is a span, so it's an event, and it represents one complete unit of work from the perspective of whatever that thing is. And that purple bar at the top is what would have been our event in the past data model, in the event data model. So instead of just attaching metadata about everything that happens underneath to that span, we're going to have all these other subspans underneath. There's a lot more choices when it comes to tracing instrumentation. The bigger vendors out there, especially ones that are coming from like an APM product, will give you an agent or some other proprietary thing to drop into your code. The cool thing about that is it'll generate spans for common operations like HTTP requests, other services, that kind of thing out of the box. On the other end of the spectrum, there's open standards like open tracing, open census. We're all blessed by the fact that those two standards are actually merging because there's been some community confusion around exactly what open tracing does and what it does or doesn't specify. So I'm really excited to see the result that comes out the other side of these two projects. Hopefully we'll get the best of both worlds, because there's things I really like about both of them. Of course, the open source benefit is great here. There's a good community around both of these, and a lot of the vendors are pretty involved in making sure that the things make sense both for end users and for the tools. I think that the thing that's slightly different is that they mostly just provide the tracing API, so you often will end up writing a little more instrumentation than you would in the vendor case. And so far, I haven't seen a huge community around there, out there building drop-in open source instrumentation. So for example, you might find yourself writing your own HTTP wrapper to be able to have good traces. Our approach is probably halfway between the two. We have an open source thing that does some simple auto instrumentation. So you get spans for DB calls and requests. It's not as polished or complete as what you get from an APM vendor, but it tends to be a little more customizable. So there's good choices there, and you can kind of choose the one that makes the most sense for your organization. And what does the code look like to send traces? It tends to be more complicated than for events. So this is the same example I showed for events. At the top, there's that helper function to send spans, add context. The bottom is the web application handler code. But you can tell that it's quite a bit more verbose. Like, don't even try to read this. My point is just, it's longer. I think, in most cases where we've migrated from events to traces, we're seeing 2 to 3 times as much code just to kind of get the basics up and running. So I said that writing event instrumentation code wasn't that scary. For traces, it can be, especially if you're using one of the more manual approaches. It can really take a lot of time, so you do kind of want to take it piece by piece. For us, the process looked like we scheduled a 1-week hackathon. We had 1 or 2 engineers focus on this as their primary hackathon project, and they kind of got all the plumbing in place for our web app. And then in the following 2 to 3 months, we had engineers, like the couple most senior engineers of the team, just in their spare time, like 30 minutes here or there, adding a little more context in places where they thought it would be useful. Now we're in the phase where we kind of feel like it's done, but if we go to debug something and feel like there's missing context, we'll just open a PR to add that back. We might change our instrumentation maybe once a month. So we spent a lot of time on that. What did we get? Funny story, this is amazing. This just happened 2 weeks ago, so the timing is really good. I had a worse story before this. Just as we shipped the instrumentation for our API service Shepherd, we started having some blips of API downtime here and there. And this can be bad because sometimes customers have alerts going off of the data that they're sending us. So if the API is down for 5 minutes, they could get paged and think their service is down. So we care a lot about API downtime. So we got an alert from our metrics saying our MySQL CPU utilization was too high, and then almost immediately afterward we get this pingdom alert saying your API service is down. So we all go scramble to figure out what's happening. By the time we start digging in, it's back up. And I think it's really neat how clearly this starts to show up with our instrumentation. So the database gets slow. You can see that in that middle graph. You can see, things kind of slowly get slower, it gets better, it gets slower again, it's kind of worse the second time. And then if you look at that lower graph, that's the number of Go routines. They start to queue up as things get slow. It turns out they actually all crash at a certain point due to memory pressure. So too many things are waiting to hear back from the database. All the API servers start to crash. And then things recover because there's less load. And then we go through the whole cycle again. So we looked at our code and we were like, okay, we see what's going on here. We have an in-memory cache in our Shepherds. Each process has its own cache. Things in the cache have a TTL that's usually like maybe 1 minute. If there's an expired value in the cache for a particular key, we let the caller decide what to do. And usually what the caller will do is, okay, stop, go query MySQL for the thing I wanted, give it back to me, and then stick the value in the cache while I'm responding to this inbound request. But our app is highly concurrent. So if the cache expires for something, lots of Go routines could all race to fill the cache and start querying for the same thing at once. So in our case, we got unlucky. We had a couple of these happen that coincided with particularly slow runs of MySQL's flush logs operation. They normally were sub-second. Some of them took 5 or 7 seconds, and that was enough to kind of tip us into this bad state. So you can see each time we tip over, it actually makes the next round worse because now the thing restarted, so the cache is cold for everything. We're racing to refill the cache. And we thought we understood this incident, but we were like, we're surprised this is as bad as this is. We feel like we understand the behavior. We've seen things kind of like this before. Why did this suddenly start taking us down? And tracing turned out to be a really great way to find the answer here. Doug, who's a new engineer on our team, starts looking through traces, and he notices something weird. The cache delete is actually happening after the cache insert. So we make use of a go routine to delete the cache so we can be more concurrent. It turns out that the go routine scheduler, when it's under heavy load, doesn't actually work the way that we imagined it might in our heads, and so it means that things can happen at very unpredictable times. So there was this race between deleting the cache key and filling the cache with a new entry. And sometimes it would fill the cache with a new entry and then delete it immediately. Not what you want. And I think the cool thing is that you can spot this pretty quickly in the trace. It would have been really hard to find without it. You can see that that cache delete call is not that far down. It's maybe only a third of the way down, and this is like, there's like 3 pages of this you can scroll through. So we try to kick that off early, and then you can see that it completes way out to the right. If you keep scrolling down, you'll actually see the entry where we try to refill the cache with a new value, which finishes first. So that's really bad. That means that the thing we're trying to do, which is have this cache to reduce load, is not working at all because we're just kind of like deleting things in a loop. And the cool thing was that this was actually still lurking after we had done an initial round of remediation. So we just sort of noticed this as we were looking through traces. We kind of managed to catch this problem that was going to make the situation worse before it actually managed to tip us over again. So that was good. So how to approach tracing? I think the best part to start instrumenting is at your hotspots. We're using tracing to kind of debug our most complicated fires, and it helps us get deep understanding quickly. I think that you can ask yourself, when are we done? When are we ready for the next step? And the unfortunate answer for us so far has been, we're never done. We always keep finding something new to instrument, and especially because you can add spans to represent everything happening in your system, we kind of just find that we get more and more granular. This is my favorite section, how not to shoot your own foot. Working with distributed tracing is new to a lot of people. I think nobody on our team had used a distributed tracing tool for their production systems when we were working on that part of the product, so there was a lot to figure out. And in retrospect, there were some things I wish we'd avoided. Data volume problems are the biggest one. So if you have a high traffic app and you instrument it for tracing, if you think about it, if you're doing 50,000 requests per second, each of those is represented by somewhere between 10 to 1,000 spans maybe. That means you're going to send 50,000 times 1,000. That's a lot of requests to your observability tools. When we started converting our API service, that's our highest volume service. And I ended up in the situation that you never want to be in, which is a surprise message from your CFO asking why your AWS bill has increased by a double-digit percentage. That was a bad day. We had to scale up the API service just to deal with the CPU load of creating this instrumentation and sending it out. Our data egress costs were up from essentially zero to like thousands of dollars. And we had also had to scale our own dog fooding cluster to handle all this traffic from ourselves. So that was not a day where we felt really smart. The thing that's going to help you out here is sampling. And thinking about this ahead of time can be really helpful, kind of planning for it. Sampling, the goal of sampling is to reduce overall data volume by sending only a representative subset of events. And you can get very sophisticated with what the strategy is for figuring out representative. For example, if you read the Facebook Canopy paper, they're doing some really cool stuff, trying to be able to sample in a smart way, Lightstep too. I would also say if you want to nerd out about sampling, one of my coworkers, Ben Hartshorn, has a great talk from 2017 LISA conference. So there's a link in here. I'll post these after the talk. So for us, for the Shepherd service, we do a fairly simple dynamic sampling approach based on customer ID and response status code. So this lets us take different strategies for different customers' traffic. We can record data about every request from a small new customer who's just getting started, so we can make sure they're doing okay, but we might sample data from a big customer at maybe 1,000 to 1 in the success case, maybe 10 to 1 in the 500 error case, because they send us so much traffic that any problem that's going to show up is going to show up multiple times. And if you do use sampling, you make sure you set the sample rate field on your events. Your tool will have some way to do this. And that makes sure your tool knows to count that event 10 times or 100 times or 1,000 times, whatever your sample rate is, and it'll actually know to draw the graphs correctly as though you had set 10 events instead of the one. People who haven't worked with sampling before often feel a little scared at the idea of throwing away data, but I think if you have a good dynamic sampling strategy, you can still feel comfortable knowing that when things really matter, they'll get through. Another place we shot ourselves in the foot was with schema churn. Like, the great thing about all these tools is that they're very flexible about schema. You can always just add new fields and send them in. But that also means that if you're changing a lot, especially if you're changing the structure of your events or traces really dramatically, it can be just really hard to navigate in the UI. So I wish we had sat down ahead of time and kind of plotted out what we wanted our schema to look like. I wish we had matched my favorite open source option, like matched one of the open census schemas. Consistency between services is really important. Just as you're kind of jumping around between systems, you really want those to look the same so that you don't have to go, oh, what's the field name over here? And this happens this, but it's terrible. And then using namespacing was really, really helpful for us. Like, you know, in a lot of cases, because we say send wide events, there might be hundreds of fields on an event, and just being able to see those in the UI next to each other, because we've namespaced them, is really, really useful. So I think the business case for adding this kind of instrumentation is really good. We have quote after quote from teams that have reduced their incident resolution time from days to minutes, and so it tends to pay off fairly quickly. If you need help with that in your organization, I do have some like case studies I can send you. But I've definitely worked at companies where it's really hard to get approval to add new code or tools, or people are really skeptical about the idea of taking time away from some, you know, from a roadmap project to work on something like this. So what are strategies that work in those kinds of organizations? The thing that I've seen work best is to start in not production. Take something that isn't your big production app, but is potentially like a big problem or pain point, and start there. And the two things that I've seen go best are instrumenting build pipelines to find like bottlenecks, or instrumenting test suites to help find and kind of quantify flaky tests. They tend to be smaller projects, so you spend less time writing instrumentation, and you tend to see that pay off in terms of reducing team pain pretty quickly. So we did this ourselves for our own build pipeline. The pipeline runs both our tests, and it generates the build artifact that we deploy. So builds are automated, they run whenever you push. The latest build is deployed to production every hour. And so if this starts to get slow, it's annoying because you're like, oh, I just shipped my change, is it in production? And you kind of have to, you know, figure out what's going on and watch it. So Tojako put this together, and he was sort of like, I feel like times are getting gradually slower, and it was a really great way to illustrate, in fact, our build times are getting gradually slower. We probably should do something about it. Each build generates a trace too, so when we start looking at these, we can say, this is how long we're spending installing dependencies, this is how long it takes to run migrations, this is the amount running the actual test takes. And we noticed that installing dependencies was typically one of the slower steps, so that's our focus now. We're trying to figure out if we can tune our caching there so that we can avoid downloading as much fresh stuff. And we found that if you use something like this, you do something positive for your team, it's a great way to get people excited about events and get them kind of understanding those event and trace data models without having to touch prod or start a big political battle. And then once you get your teammates kind of thinking that way, hopefully they can kind of be your allies in figuring out how to pitch this to the rest of your organization. Cool, that's all I got, thank you. I will tweet out the slides, and there's links to a bunch of blog posts that kind of go into more depth on some of the things I talked about. So that'll be on Twitter if you want to check that out. I also have a lot of stickers that are like nihilist, Lisa Frank, observability stickers, and I really don't want to take them home with me, so please come see me after the talk if you want one of those. Awesome, thank you.